Hello everybody, and welcome back to another delectable episode of Maths. In the last video, we discussed how to convert between mixed numbers and improper fractions, which we saw previously were just two different ways of expressing numbers that had a magnitude bigger than 1. And in today's episode, we are going to just get some practice converting between these two bad boys, and yeah, all will be good in the world. So as usual, try these problems out for yourself. And once you've given that a good, honest go, because honesty is the best policy, then we will start up with them together. Question 1 says convert the following mixed numbers into improper fractions. So the method we saw for this was to essentially think about this as being the whole number plus the fractional part. So this is 3 plus 5 over 6. And in order to add these, we can think of 3 as an improper fraction out of 1. And now all we need to do is to make a common denominator between these two. And since we have just a 1 in the denominator here, the fastest way to go about that is going to be to multiply the numerator and the denominator both by 6. That's going to give us 18 over 6, which makes sense since 18 divided by 6 equals 3, plus 5 over 6. And that equals 23 over 6. So that is our improper fraction version of that mixed number. And again, the faster way to do this, that basically does everything we did here, just a little less of the actual theory is demonstrated in this technique, is just doing 6 times 3 plus 5. 6 times 3 plus 5 is going to be 18 plus 5, which is 23, and then all of these are over our original denominator. So both methods work. Again, this one kind of tells you why we're doing it, but this one is faster. All right, let's do part B. So we have 20 and 1/8. Okay, so we can think about this as 20 plus 1/8, which, to make a common denominator, this is 20 over 1. Multiply the numerator and denominator both by 8. So now we have our common denominator. So we get a fraction of 160 over 8 plus 1 over 8. And combining these, we get 161/8. All right, let's do part C. This time we have a negative number. So negative 4 1/3 we have to think of as negative 4 minus 1/3, because both of these parts, both the whole number and the fraction part, are negative. So this needs to both be negative, but that's not going to change too much else about the process. We make this into a fraction out of 1 so that we can make our common denominator of 3. This becomes negative 12 over 3 minus 1/3. So we're looking at negative 12 minus 1, which is going to be negative 13 over 3. Again, we can think of this as 3 times 4, which is 12, plus 1, which is 13, but make sure there's a negative there, and we get to negative 13 over 3. And let's do the last part here, part D, negative 12 and 11/12. All right, so for this one, this is negative 12 plus 11 over 12. 12 is the same thing as 12 over 1. Denominator is going to be 12, so we multiply the numerator and denominator by 12 each. What's 12 times 12? Hopefully you remember this from your times tables. That's 144, but it's going to be negative 144 because of our negative 12 times positive 12. All of that over 12, and then we're adding 11 over 12 like this. Now, do you see where I made a mistake? That's right, right here, it should be negative 11 over 12, not plus 11 over 12, right? So these should be negatives, not addition. And we are going to get negative 155 over 12 as our final answer. So remember, if you have a negative here, it's both this and this that are negative. Both the whole number and the fraction part are negative. So it's negative 12 minus 11 over 12, not plus like I did right there. Okay, so that's question 1. And if you want some extra practice, just make up your own mixed numbers and convert them into improper fractions, just like we did here. All right, let's move on to question 2. All right, question 2 says, convert the following improper fractions into mixed numbers. All right, so our method with this is basically we need to think that 40 over 3 is the same as 40 divided by 3. And then we can do long division and go from there. So 40 divided by 3. 3 goes into 4 once. Subtract off the 3, we get 1. Bring down the 0, we have 10. 3 goes into 10 3 times because 3 times 3 is 9. which we'll subtract off and get a 1. And now we're done, right? 1 is our remainder, so we get 13 remainder 1. So the way we write this as a mixed number then is we get 13, right, from doing 40 divided by 3, and then the remaining 1, that's still being divided by 3. So that is the 1/3, that's the fractional component of our mixed number. So our answer is 13 and 1/3. Let's do part B. 310 over 9. Okay, so once again, this is just a long division problem where we're stopping at our remainder. 9 doesn't go into 3, so we have to look at 31, which it goes into 3 times, since 9 times 3 is 27. Subtract that off, we get a 4. Bring down the 0. 9 goes into 40 4 times, since 4 times 9 is 36. Subtract that off, we get a 4. Okay, so we have our remainder of 4. So basically 310 divided by 9, that's 34, and then the remaining 4 is still being divided by 9, so that is the 4/9, the fractional component of our mixed number. Part C, we have a negative this time, so we should expect a negative answer, since a negative divided by a positive is negative. But in the actual division, we just need to focus on doing 23 divided by 8, because we can add the negative on afterwards. 8 doesn't go into 2, but it goes into 23 2 times. Right, 8 times 2 is 16. It almost goes in 3 times, but 8 times 3 is 24, so it's a little bit too big. So we have to just go for 2 times. 2 times 8 is 16, subtract that off, we get 7. So what we get here is going to be 2 remainder 7, and that 7 we write as 7/8. But again, this is all negative, right, because of that negative in front of our 23 there. All right, and the very last one, you're probably getting the hang of this by now, negative 111 over 11. A lot of ones here, but that's all right, no different than anything else. So how many times does 11 go into 1? It doesn't. How about 11 go into 11? It goes in exactly once, right? So we subtract off 11, and we get a 0. Bring down the 1. 11 can't go into 1, so we have to put a 0 there. And we actually are done, right? Because, well, we have this remaining 1 still. So this ends up being 10, remainder 1, with our 1 being out of 11, right? We put the remainder over our original denominator. And this also needs to be negative, right? I didn't write a lot of room here. So this is negative 10 and 1 over 11. Okay, so hope that made sense. And if you want some extra practice, same with number 1, make up your own improper fractions this time, both positive and negative, and convert them into mixed numbers. Let's move on to question 3. So question 3 says convert the following improper mixed number into a proper mixed number. So this is a little bit informal. Mixed numbers, they are always a number and then some fraction, and it's a regular fraction, so it's not an improper fraction. But here I have the whole number and then an improper fraction there, so that's why I'm calling it an improper mixed number. That's not really a thing that usually happens. But in this question, we're going to assume that you can do this, 5 and 13 over 4ths. But we don't like this because, well, we know that mixed numbers should only have a proper fraction inside of them, so that's what I mean here by a proper mixed number. So basically, if I wrote 5 and 13/4, how could I put that into a form that we're more comfortable with, a proper mixed number? All right, well, to start with, we should maybe just focus on how do we make the 13/4 into a fraction where there is not a bigger numerator than a denominator. Well, that could be done by converting 13/4 into a mixed number. Okay, so if we convert 13/4 into a mixed number, well, we just did that in question 2, right? We just do 13 divided by 4. 4 goes into 13 3 times, and we get a remainder of 1. So 13/4 is the same thing as 3 with the 1/4 remaining. So that 13/4 now is a mixed number. But how do we deal with this 5? Well, remember what mixed numbers are. Mixed numbers are just the sum of the fraction and the whole number, right? So we can split this up into 5 plus 13/4. But then we could replace this 13/4 with this 3 1/4 we just found it to be equivalent to. So we get 5 plus 3 1/4, and we can split up 3 1/4 into 3 plus 1/4, right? So I just split up this 3 1/4 into 3 plus 1/4, and now we can do 5 plus 3, which is 8, plus our quarter. So now the proper form of this mixed number will be 8 1/4. In reality, you're never going to be getting a mixed number where there's an improper fraction as the fractional part. The whole point of a mixed number is to not have an improper fraction. But if you came across something like this, you'd say, hey, well, I can actually convert it into something that is proper, right? So that's just kind of the little playground question of question 3. Let's go on to question 4. All Alright, so this says, I have 43 friends, all of whom I need to give a slice of cake that's the size of a fifth. How many cakes do I need to bake? Use improper fractions and mixed numbers to arrive at your answer. So basically we're making a cake, let's say it's a rectangular cake, and we want to split it into 5 pieces, and each friend gets one of those pieces. Alright, so that makes sense. But there's 43 friends that we need to share it amongst. You know, I'm a popular guy. People just love my math videos. They want to be friends with me. So I have 43 friends. And so 43 people need one of these slices that are size of a fifth. We can think about this as 43 pieces of size 1/5. So that is the fraction 43 fifths, right? So that's the improper fraction piece done. But we need to actually know how many cakes we need in total, right? 43 over 5, yeah, we know how many of these pieces we need, but it doesn't give us too much information on actually how many of these full cakes we need to bake. So what we can do is if we convert this into a mixed number, that's going to give us basically the whole number component, and that whole number will tell us how many cakes we need. So let's do 43 divided by 5, right? We're just converting this into a mixed number. 5 doesn't go into 4, but it goes into 43 8 times, right? 5 times 8 is 40, so subtract that off, we get remainder 3. So 43 and a fifth is the same thing as 8 and 3 fifths. So if we made 8 cakes and then we had 3 additional slices, then we'd be able to give all 43 of my friends a slice of size 1/5. So how many cakes do we need? It's not going to be quite 8 because we need this 3 fifths, right? We need more than 8. So in total, I need to bake 9 cakes, right? And then everyone will get a piece, and then there's just going to be 2 slices left over, which I will greedily indulge in. So we see that this is kind of a nice application of using improper fractions to determine how many things of a certain size we need, and then converting it into a mixed number to give us a more intuitive understanding of what quantity we actually need. We need a little more than 8, so we need 9 in total, right? 43 over 5 didn't quite show us that, but it did show us that we needed to basically give 43 people a slice of size 1/5. Alright, so I hope you can kind of see some of the utility of both improper fractions and mixed numbers. And let's go on to question 5. Aidan goes to convert his improper fraction to a mixed number. He starts by doing long division, and it turns out there's no remainder. What does this mean about his original fraction? Okay, so he's got an improper fraction, and we know the way we convert improper fractions into mixed numbers is dividing them, and then we use the remainder to give us the fractional part, right? For example, 40 over 3. If we do 40 long divided by 3, we get 13, and then our remainder is 1, so we get a third as the fractional piece, right? But the problem is that when he divides it, he doesn't get a remainder. Well, what does it mean when you don't get a remainder when you divide a number? Well, let's do an example. If I did 12 divided by 4, 4 goes into 12 exactly 3 times, so we don't get a remainder. So what this is saying is that if we don't get a remainder, basically the number that we had inside of here was divisible by what we were dividing by. So in that case, right, this fraction we would think of as 12 over 4, and we ended up getting 3. That's because 12 divided by 4 is 3. We can basically say that his original fraction's numerator was divisible by his denominator, right? 12 is divisible by 4. That's why we don't get a remainder when we divide it. That was the whole point of divisibility, right? We don't get a remainder, we don't get a decimal when we divide them. So we can say then his fraction's numerator was divisible by the denominator. Alright, so his fraction definitely wasn't simplified because it was divisible by the denominator, but it was the fraction that he started with, right? And we see here that we can have improper fractions like that, right? 12 over 4 is an improper fraction. It's just one that can be simplified, right? But if he didn't know that ahead of time and he tried to convert it, doesn't get a remainder, well, then he'll see that, yeah, it was actually divisible, right? There was no remainder. Yeah, so that's question 5, and that's all the problems. I hope you found them useful, and I hope you're feeling a little more comfortable with converting between these two worlds of improper fractions and mixed numbers. Before we kind of continue on with doing some of these things, the next video I have a cool little mental math trick for you in terms of converting from fractions into decimals. So I hope you're excited for that. I know I sure am. But until then, you have a good day, you stay groovy, and I'll see you in that next video.